Alright, so let's say you're given this diagram here of a ball being thrown on a curved path, and the question asks you to find the work due to gravity for the ball's motion. To start, we need to know the gravitational potential energy for motion across a curved path, since the work that gravity is going to do is equal to the negative change in the gravitational potential energy. This is for the general case, so how does this change on a curved path? So to find the work done by gravity over a curved path, we divide the path into a small segment, delta S. This is our path here. We take a small segment. You can denote this direction as delta X, and then this direction as delta Y. The total displacement is delta S over this small path. And our force of interest is the weight force, mg, pointing down. Sorry for the error here. It's actually supposed to be negative y hat, not just y hat, because it's in the downward direction. We can also define delta S as delta x, x hat, plus delta y, y hat. The unit vectors just indicate the directions of motion. But we know that work is equal to force times displacement. Force is going to be our weight force, which we defined earlier, and our displacement is going to be our displacement vector, which we also defined earlier. So we plug both these in, and then we can distribute the mg, y hat to both brackets. We can look at the first term here. It's going to be y hat dot x hat. And if you remember the dot product, it's equal to the magnitudes times the angle between them. So if we look at the angle between x hat and y hat, is 90 degrees. Unit vectors, the amplitudes of the units are both 1, so we're just going to get 1 for that. If we compute a dot product, 1 times cos 90, cos 90 is equal to 0, so for this term, it's just equal to 0, and this makes sense because the force of weight is perpendicular to the displacement in the x direction. So this means gravity doesn't do work on the ball in the x direction. We're left with this term here, and I make the correction identifying that the weight force is in the negative y hat direction as seen by this diagram. If we take the angle between them, the angle between negative y hat and y hat is 180 degrees. So if we take the dot product of the unit vectors, the amplitudes are just equal to 1, and then cos 180 degrees is equal to negative 1. So we just get negative mg delta y for the answer for that. And if you remember, we're calculating the work due to gravity. So the work due to gravity is going to be equal to this term here. Then we can plug in our definition for delta y and distribute the negative sign, and we actually just arrive back at our original equations. Even though the motion is in a curved path, gravity only does work on the object in the y direction. We can apply this to our example. We can identify y1 as equal to 0, and then y2 is going to be equal to 5 meters. This is going to be the maximum height. And then we can plug in our other known values, and we get this expression here. And we can cancel out the 0 term, and then we can compute the amplitudes in the units of the right term. And if we do that, we get this for the final answer. This is the work done by gravity over the motion of the ball getting to the maximum height. So this value here makes sense, being negative 49 joules. As the ball gets to the maximum height, the displacement is in the opposite direction to the force of gravity. The displacement is pointing up, and then the force of gravity is pointing down, so this makes sense.